Alrighty, welcome back everybody. It's your main math man, Mr. Shank, coming to you live from Summit Academy. And in this video, we're going to be working on that Unit 6 practice test for that Math 2 class. Alright, so what we're doing here, really simple stuff. First part is, all we have to do is graph out this equation. So we got a quadratic equation over here, and we're just looking for these x-intercepts. So I'm going to say graph, and look for x-intercepts. Again, I have plural on here because usually there's going to be two because our degree is 2. So right away what I can also do is I can kind of cross out 2 answers because, hey, for A and B, those only have a single x-intercept, and we need more than that. So let me pull up Desmos real quick. I'm going to graph out that right side of my equation. So I'm going to say x squared. So we say x squared, then we say plus 9x plus 20. And so we look for, again, where it hits the x-axis, meaning where y equals 0. So on the 2 points that I click on, notice how my y value is 0 for those 2 points. And I can pick my 2 x values. So x equals -5 and x equals -4. To be able to graph that out and select your answer. So we're going to say this one is going to be D. All right, same idea for this one. Again, we talked about kind of getting those values as a GCF, but for right now, again, just graph out, same idea, graph and look for x-intercepts. Again, that's where y equals 0 or where my curve hits the x-axis. So I'm going to go back to my graph here. Let me pull that up. I'm going to say, okay, clear this one out. So now I'm going to say 3x squared plus 36x plus 96. All right, there's my 2 curves. Again, if you don't see your function, you can always move it around or zoom in or zoom out. But I can get those 2 points, again, where the y value is 0. So I'm going to say x equals -8 and x equals -4. Let me circle that answer then. And x equals -8 and x equals -4. So we're going to say C for that one. So first 2, really easy. Don't have to show your work. Just be able to graph it out and solve. Moving on to number 3 though, this is where we're going to do a few steps here. So it says study the equation. I have x squared plus 7x equals -12. And it says solve the equation by completing the square and make sure you show all the work. So what we're going to have to do is we have to kind of use those 2 posters that we talked about. I have to complete the square first, and then I'm going to solve in vertex form. So first step, so I'm going to say I have x squared plus 7x equals -12. So first step I have to do is I have to set equal to 0. And so how you do that? Well, I can add 12 because it says a -12 here. So I'm going to add 12 to both sides. Again, do not combine unlike terms. So since the 7x and the 12 don't share a variable common, they are not like terms. So I'm going to say I have x squared plus 7x plus 12 equals 0. And now I can follow my poster that I have. So I have to identify b. So I'm going to say b equals 7. Then I say b over 2 is equal to 3.5. And then I say b over 2 squared is equal to 12.25. And if you're wondering how I got these values, again, make sure you're seeing, again, b is really easy to identify because it's the value that is attached to that variable x. I can calculate that really fast too. Let me show you how to do that. Like this, I can say, okay, look at your equation. And we said b equals 7. So I can type in b equals 7, and I can type in the other parts I need. So now I hit enter, and I say b over 2 is equal to 3.5, and then I type in b over 2 squared or exponent 2, is going to be, or raised to the power 2, I should say, is going to be 12.25. So that's where I get my numbers from. Again, I'm able to calculate those carefully. All right, so once we have those, we're going to say we have this. So I'm going to add that number now to both sides. So I'm going to say, okay, I have plus, so I do plus 12.25 to both sides. So I need to add the number to both sides. So I say, okay, I have x squared plus 7x plus 12.25. Again, those are going to be grouped together, so I put those in parentheses, and then I have the rest of my equation. So I still have that plus 12, and I still have equals 12.25. So now I can switch my forms. So again, in my equation, I have to write my b over 2, and I'm going to say x plus b over 2 because I have a plus 3.5. If this was a negative 3.5, I would have to include that it's negative 3.5, and I would write it in there. But for right now, since it's plus, I'm going to say plus 3.5 squared, and then the rest of my equation, which is plus 12, equals 12.25. All right, and then my last step is to get it set equal to 0 again. So I'm going to subtract 12.25 from both sides. Again, keep that grouping symbol of the parentheses separate. So I'm going to just subtract right here. So I'm going to say altogether, I have x plus 3.5 squared minus 0.25 equals 0. And this is going to be helpful because this is now our vertex form. Once we have our vertex form, we can start up here now. So I'm going to say, okay, now that we have a vertex form, I have x plus 3.5 squared minus 0.25 equals 0. Now I have to solve in my vertex form. So again, over here we did complete the square. And then over here I have solve vertex form. Because we're solving for x, so I have to solve for x. So what I'm going to do is I'm going to add 0.25 to both sides. I'm going to add 0.25 to both sides, so I have x plus 3.5 squared equals 0.25. All right, so now we have this. Now we can do the key step. Key step is to take that square root because I need to get rid of this exponent 2. So now I take the square root of both sides, take a square root of both sides. And what you could do is if you want to, you can keep writing that square root down, or you can evaluate it either way it works. I'm just going to write keep it as the square root, so that way it's a general answer. But for this, on the left side, the parentheses go away, so now all I have is x plus 3.5, and then I have equals plus or minus. So when you take a square root of number, usually you're going to have a positive answer and a negative answer. So to signify that, or to show that, I'm going to have that plus or minus symbol. So now I have plus or minus square root of 0.25. All right. This is where we split our work at. So I'm going to say, okay, split our work to be able to say, okay, I should have two sides here. So now I can say I have x plus 3.5 equals negative square root of 0.25. And then I could say on the other side, I have x plus 3.5 equals positive square root of 0.25. So this is the key step. Again, we're taking our two answers that we have and we're splitting them into two possibilities. It's the same inverse operation the whole way across. So I'm going to say I have minus 3.5 the whole way across. So I say minus 3.5, minus 3.5 the whole way across. And this will get x by itself, and it will give us our final answer. Please be careful though. A lot of people are trying to subtract inside that square root symbol. Make sure you keep these values separate. So I'm going to say, I keep them separate. I'm going to say x equals negative 3.5 minus square root of 0.25. And I'm going to say x equals negative 3.5 plus square root of 0.25. And I actually skipped a step here because I wanted to check my work partway through. But what you can do is this. So to check your work, let's say I got down to this vertex form and I said, hey, I don't know if this vertex form is right. I didn't have any decimals to start with. How did I end up with decimals? Well, we could check it out. So what I'm going to do is I'm going to pull up my graph and I'm going to graph out my original equation. So my original equation was x squared plus 7x. And we said plus 12 because we added 12 to both sides. Okay, so there's our original graph. And what I could say is let's check our vertex form. So I said my vertex form was x plus 3.5 squared. I said minus 0.25. And if you look, notice how it barely changed. But again, notice how I have overlapping things. And an easy way to check that is those 3 key points. I have 2 x-intercepts and a vertex. I'm going to say, is it the same as my other point? So let me cover this one up. And I'll say, is it the same as my 2 x-intercepts and my vertex? It is. So since they are the same, that just means they overlap. Like so. Notice how they overlap because they are the same. They are equal. And now I could say, okay, well, I got my answer at the bottom here. I got my answer for my 2 x-intercepts, and I'm saying, well, I don't see those on the graph. How can I check? Well, I can say, I'm pulling up my equation or my graph as well. So here's my vertex form, and I'm saying, okay, I'm going to compare those 2 x-intercepts. Well, I said one x value was negative 3.5 minus square root SQRT of 0.25. And then the other one was negative 3.5 plus square root of SQRT of 0.25. So notice how, again, those 2 x-intercepts are exactly what we have for our 2 answers. So even though we have a kind of messy looking answer, we can get that they are going to be the same numbers. Again, you might have decimals. That's okay. It will be fine. Alrighty, so let me clear that out. And let me go to the next one. Alright, on the back now, it says for part A, solve the equation for x, and we get x squared equals 324. And make sure you're remembering this key part. When we take a square root of a number, we should get a positive answer and a negative answer. I can kind of show us how this works. So we have x squared equals 324. I can take a square root of both sides. Please do not type in this left side because it's going to try to graph it out. But what you can do is you can type in the right side exactly as it looks. So like this, I'm going to say I have square root, so SQRT of 324, and I get 18. But if I notice, I have, let me actually show this to you guys. Sorry, I kind of skipped that. Let me try that again. So I'm going to say SQRT of 324. So I get my positive answer, but I also have to have my negative answer. So I just need to list out that I have negative 18 as well. And I can demonstrate that on the graph as well. So I can say, okay, one of my equations is x squared, and my other equation is y equals 324. So what you have to do is when you have this graph, graph out the left side of your equation, graph out the right side of your equation, and find where they cross. So for this one, I'm going to have to zoom out a bunch, but I find where the two lines meet. And if I look at the x values, notice how my x value is negative 18 and positive 18. So that kind of reinforces that idea. Let me take that away, and let me write down my two answers here. So I'm going to say my two answers, very easy. I have x equals 18 and x equals negative 18. Those are going to be my two answers. All right. Moving on. Same kind of stuff in the as the front side. I need to set equation equal to 0. So my first step is, since I have equals positive 4, I'm going to say I have to subtract 4 from both sides. So I subtract 4 from both sides. I say 4x squared plus 15x minus 4 equals 0. And then this one's really easy because all we have to do is just graph out this right side. So let me underline that and say graph out. So what it looks like is like this. Let me clear this one out, hit home, and reveal it. All right. So on this one, we're saying, okay, after I subtracted 4 from both sides, my new equation is going to be 4x squared plus 15x minus 4. To be able to find those two values, so one of my x-intercepts is going to be negative 4. One of my x-intercepts is going to be positive 0.25. So let me say graph and look for x-intercepts. So I'm going to say x equals negative 4 and x equals 0.25. And let me double check those answers one last time. Yeah, okay. Clear that out, and we're good. All right. So again, on this back part where there's 4 parts, I need at least 3 out of these 4 parts. So even if you struggle with them, that's okay. Again, make sure you're seeing how to do them. So for part C, it says the formula for kinetic energy is shown below. Rewrite the equation easily to determine the velocity of an object. That just means solve the equation for V. And so our end goal, let's say our end goal is V equals something. So we should have that V is all by itself. All right. So what it looks like is like this. Let me rewrite the equation. I'm going to say E equals mv squared divided by 2. So if I have something times 1/2, that's the same as dividing by 2. And since we're dividing by 2, I can use my inverse operation. So first I'm going to multiply by 2. So I'm going to say multiply both sides by 2. Multiply both sides by 2, cancels out on the right side. On the left side, we're left with 2e equals, and then on the right side is mv squared. Again, I don't know any of these values, but that's okay. We're just trying to rearrange this equation. So next step is to divide both sides by m. Divide both sides by m. On the right side, it cancels out. On the left side, it stays the same. So I have 2e divided by m equals v squared. And if you remember on that part A that we did, when we say we have an exponent 2, we have to take a square root, but when we take a square root, you need to have 2 answers. So I'm going to say square root of both sides, and that will give us our answer. So I'm going to say v equals plus or minus square root 2e divided by m. That's going to be our final answer. And then that last part, part D, bunch of different stuff to go over, but it's just saying this. It says a circular pool of oil grows so that the radius increased by 2 feet. The formula shown can be used to determine the area of a circle. So as area equals pi times the radius plus 2, in parentheses, squared. Then it says Amelia wants to determine the radius of the original circle based on the approximate area covered in oil. She decided to complete the following steps to solve her equation for the radius r. So it's very similar to that part C where you're just kind of rearranging these pieces. So it has a list of steps given, but it says Sonia is reviewing Amelia's work and disagrees with Amelia. Identify Amelia's mistake, why this step will not work, and then model the correct solution process for Amelia. So a couple different things with this. You have to be able to find the mistake. That means say, okay, step blank is incorrect because of this reason, and then you say and show what the correct work is. So for this one, the step 1 is given, so it can't be step 1. But in let's say step 2, they took a square root of both sides, but we can't do that because of that pi symbol in front. So we're going to say this. Let's say the mistake is in step 2. And we could say if they take a square root of both sides, they would let's try that again, need to take the square root of pi. So instead, what we're going to do is we're going to show our work and be able to solve it. So what I'm going to do, my steps on so let's say, let's mark it here. Let's say correct steps. It's up on the side here. We're going to say, okay, we start with a equals pi times r plus 2 squared. What I have to do first is I'm going to have to rearrange this function. So I'm going to rearrange this equation. So I'm going to say, let's divide by pi first. So I'm going to divide both sides by pi. So now I have a over pi equals parentheses r plus 2 squared. Now we can take the square root of both sides. So I'm going to say square root. And so up here, let me not draw that arrow. I'm just going to say, oh, sure. Now up here, I'm going to say plus or minus square root of a over pi equals r plus 2. And then our last step to get r by itself is to subtract 2 from both sides. Again, keep that 2 separate from that square root symbol because that square root symbol, that radical symbol, is its own grouping symbol. So I'm going to say subtract 2 from both sides. All together, we get this. We're going to say r equals -2 plus or minus square root of a over pi. That's going to be the answer that we're looking for. So it's similar to kind of what they had here, but if you notice how that square root symbol does not include the pi in Amelia's work, so that's where the mistake is. So make sure you can try these out. Again, I only need parts A, B, and C on the actual test, so just make sure that you're doing at least those 3 parts. Otherwise, be sure to ask questions as they come up. Use that Desmos graphing calculator to your benefit. And as always, super slam that subscribe button.